Now that we know where the slope shows up in the equation and where the positioning or y-intercept shows up in the equation, we can write the equation by finding slope and positioning. Okay, so let's work on starting with points. Okay, we can draw a graph here with these 2 points. Okay, so it looks like 3 and 5 maybe somewhere around here, 9 and 13 maybe somewhere around there. We get this line that looks kind of like that. So if we can determine the slope and y-intercept position of this line, we can write the equation of this line. So I'm going to start with the slope here. Okay, so I want to find the slope of this line. So I want to find the change in y. So the end position is 13, the starting position is 5. So in this case it went up 8, and I can see it's going up. And then the change in x, my starting position, my ending position for x is 9, minus 3 is plus 6. Okay, and again, make sure that we're clear that the y is a vertical, it's the second coordinate, the x is a horizontal, it's the first coordinate, and you pair those up. So once I have my change in y and change in x, I know that my slope is going to be y on top, x on bottom. I'll simplify that ratio to 4/3. So I've got the one part of my equation already, and I just have to figure out where it crosses the y-axis. So there's a few ways I can do this. I can kind of count backwards. Okay, and I know that if I go backwards 3, I go down 4. So I can go backwards 3 to 0 and down 4, and I can maybe show this in the table a little bit better. But there's my x, there's my y, there's 3 and 5, 9 and 13. And I know my progression is, if I go minus 3 to 0, I would go minus 4, because that's my ratio, to 1. And I can find my y-intercept that way. So my y-intercept is, in fact, 1. Okay, so that's one way I can do it. Now this worked out really nicely because of the numbers, and I can kind of see that that would be my y-intercept here. So it looks like about 1. This is maybe not the most efficient way to do it. So let's look at another way we can do this. So another way we can do this is, once I have the slope, I know my equation, I know part of my equation. So I'm going to write down what I know. I know my slope is 4/3. And I don't know my y-intercept. Okay, so although I calculated here, let's assume that we don't know what the y-intercept is, and we'll look at another way of finding it. Okay, so I'm just going to write down that this is, one way to do it. This is a second way to calculate the y-intercept. Okay, so what am I going to do here then? Well, these are x and y's in the equation, or x and y pairs, and I know that these are x and y pairs. Okay, they go together. And any x and y pairs that go together have to fit into the equation. That's a really important concept. If I have a point on the graph, it has to fit into the equation. I have to be able to plug it back in. And that's a really, really, really important piece that we can use anytime, no matter if we're doing, grade 8 math or AP calculus or anything beyond that. If we have a coordinate pair, if we have a pair that is a relationship, it can always fit back into the relationship. So I'm just going to choose one of these 2 points. It doesn't really matter which one, because they both are going to fit into this equation. And notice what happens. I'm going to put x is 3 and y is 5 into this equation. Okay, I already knew my slope was 4/3. And then what ends up happening then when I plug in the x and y into this equation is that I only have one variable left in this equation. Well, if I have one variable in my equation, I have to be able to solve for that b. There's only one variable in there, so I can isolate the value of that b. So that's what I'm going to do. And I should expect it to equal 1, because I saw that, by my table on my graph, it looks like 1. So when I plug it in, calculate this, times 3, divide 3, cancel out, and I'm left with a plus b on this side. I subtract 4 from both sides, and yeah, I get the value b equals 1. Okay, and this is the value that I saw in my table. I also can see that that's, if I drew my graph accurately, that's about the right spot. So we've then found the slope by using our slope ratio, by using our triangle, and we found the y-intercept using, we can use a table, but probably better way to do this, a more efficient way to do this, is to just plug in one of the two coordinates that we were given here. I plug in an x and y into that equation. And that gives me an equation which I can solve for b. Okay, so I'll just highlight here, that's my x and y, and I plugged in x and y into there. And I just arbitrarily chose 3 and 5. I could have used 9 and 13. And again, when you do that, just make sure you put the x in the right spot, the y in the right spot, okay? Because they're in different order here that we actually plug in here.